Today we're solving problem 35. In this problem we're shown the number 197, which is called a circular prime because all rotations of the digits 197, 971, and 719 are themselves prime. There are 13 such primes below 100. How many circular primes are there below 1 million? I'm going to solve this problem in 2 steps with one video for each step. In this video, we're going to be writing the utility functions that we're going to need to solve this problem. The first utility function we're going to need is being able to calculate all of the prime numbers below 1 million, because we know that a circular prime must be prime itself. So we can do a quick filter by only looking at the numbers which are prime before checking if they are circular prime numbers. Now, one way to calculate all of the prime numbers below 1 million is filtering all the numbers from 1 to 1 million and checking if it is prime. But we can do better. We can use the sieve of Eratosthenes to calculate all of the prime numbers below a given limit. So here they have a GIF. I can reload it. The way it works is it starts with the first number, 2, and removes all multiples of that number from the list. Then it looks at the next not removed number, 3 in this case, removes all of those multiples, takes 5, removes multiples of 5, goes at 7, removes multiples of 7, and then now, once we're past the square root of the limit, we can start looking and counting all of the unmarked numbers, and those are prime numbers. So let's start by implementing that. Here I have the Euler 35 app, but since it's a utility function, I'm going to implement it in the util object. So def sieve, and we're going to take a limit of type int. Now, the first thing we want to do is create a set of all of the numbers that have not been eliminated yet. And since it's going to be mutated, we need to import scala.collection.mutable. Then we're going to create a val nums is going to be a mutable.set. So this is going to be a set of integers, and the elements in nums is going to be 2 to limit, and since this is taking a vararg, we can do :_*. So now we have a mutable set of 2 to the limit. Now what we want to do is we want to iterate through all numbers from 2 to the square root of limit and eliminate multiples of those numbers. So we're going to do 2 to math.square root of limit, and we need to convert this to an int. And for each of these, we can take the number n, and we want to go from n squared to the limit and knock out those multiples. So we can do n times n to limit dot for each. Well, first we have to actually, before we eliminate, we need to check is n in nums itself, because we may have eliminated n earlier. And so we only want to knock out multiples of n if n has not been knocked out. So if nums dot contains n, then we want to do this knocking out. And in our for each, all we have to do is do nums minus equal to the number. So this is going to remove that number from nums. And now all we have to do is return nums.toSet to convert it into an immutable set. And this is going to be returning a set of int. Now I can go to Euler 35 and println util.sieve. Let's go up to 100 and see all of the primes under 100. I'm going to convert this to a seek and sort it so that we can see them in order. Now I can go ahead and run. And looks like we only got 2 and 3. Well, let's take a look and see what went wrong here. So we started out with 2 to our limit. Our limit was 100. Then we went to the square root of the limit. And for each of these, we started from n squared. Well, let's println n here so we can see which numbers are getting looked at. Okay, so we're only looking at 2 and 3. Now we can debug here. So println math.square root of limit. So that seems normal. Now let's println n for every step here to see that it's getting that far. Okay, so it's doing all of those. Now let's take a look at nums. Let's println the starting. Okay, so it seems to have all of the numbers. What could be going wrong here? Why is nums not containing n? Well, I know exactly what's going wrong here. So what are we doing here? We take each number 2, and we're doing 2 squared, which is correct. We're going to the limit, but we're knocking out every single number in between. We only want to knock out the multiples of n, so we have to do by n. And now if we run, we get a list of all of the prime numbers below 100. So now I can remove those printlns. So that completes our first utility function, calculating all of the prime numbers below a given limit. Now we have 2 other simpler utility functions. The first one is going to be taking a number and getting all of the digits in it. So we're going to create a def digits, takes a num of type int, and this we're going to do a quick and dirty way of getting the digits in num. We can do num.toString, and then on each digit we're going to take the character for that digit and do .toDigit. ToString map, not 2-digit, as digit. Okay, so now digits, now we can try out digits. We can println util.digits and 1, 2, 3, run, and we get 1, 2, and 3. So now we have a way that given a number, get the digits in this. And lastly, we want to calculate the number of digits in a number. And this we can do with log 10. So we do math.log10 of num. We're going to convert this to an int to round it down and add 1. Now we can calculate the number of digits in 1, 2, 3, and this should give us 3. Now we can check some edge cases. So we can try 100, which is a power of 10. That gives us 3, so that's good. And we can try 9, and we get 2. So it looks like our num of digits function is good. And that's it for writing our utility functions. I'll see you next time when we actually solve problem number 35.